Hello, everybody. Thank you so much for joining us for Get More from Graphical Analysis, exploring basic and advanced tools. I am joined today by two fantastic experts, and we are going to guide you through a lot of amazing features that you may not know about in graphical analysis. During today's webinar, we want to hear your questions, so I'd love to direct you to your Zoom window. In the bottom of your Zoom window, you may see something that looks like a chat bubble. When you click on that chat bubble, you'll pull up the meeting chat. This is where we're going to take your questions. Now, I want to make sure that when you submit your questions, before you hit send, you look at that little to section. It's right on top of where you type. It'll say to, and then I believe the default is host and panelists. I would love to encourage you to instead set that to everyone. We ask that you do this for two reasons. One, because it kind of encourages knowledge sharing. Not only can we learn from one another, but also other people are probably wondering the same things you are. If you ask your question there, other people will be able to ask their questions. We also ask you to set that to everyone so that when we answer your question out loud, we don't sound like we're talking to ourselves. So please, when you send a question in the chat, make sure that to section is set to everyone. To practice this new skill, go ahead and let us know in the comments. Let's see. What is your favorite way to gear up for the fall season, specifically fall teaching or decorating your home? What is a fun? Jared shares bourbon. Let's see. What else? Nice. Brit agrees. Brit agrees. Alan shares fire pits and friends. That's lovely. Cleaning the lab. Yeah, Sally, that is a necessary part of getting ready. We've got more, lots of foliage and pumpkins. Yeah, I'm seeing pumpkins out at stores now. Beautiful. We've got prayer, apple orchards, rooting for the Buffalo Bills. Making salsa from all the garden treasures. Yeah. Let's see,
Saw
stock.
something on coffee.
Yeah. Let's see, canning, apple spice. Ooh, apple spice. Sewing new pillowcases. Too
Ooh,
many trips to the costume shop. Yep, Randy, I totally feel ya.
still summer in Florida.
Yeah. Enjoying pumpkin spice.
Yay, coffee.
Yes. Apple cider, fall festivals. Yep, yep. Prepping experiments and football. How about experiments with football? If you have our, and this is not a promotion, if you have Vernier Video Analysis, you can do some football-y experiments. We've got an example on our Instagram account, which I may or may not run. That could be a could be a plug. I don't know. All right, my friends, it seems like we are all in the chat, ready to go. We are 2 minutes past the hour, and I want to make sure that we have the most time today as we can. So I will hop into some housekeeping items. As always, you will get a recording of today's webinar. It usually takes us about 3 to 5 business days to get it edited, but as soon as it's ready to go, it will be uploaded on both our website and our YouTube channel. So keep an eye out there. When it's ready, I'm going to go ahead and email it to you too. So keep an eye on your inbox. In about a week, you'll be getting a copy of the recording. In that email, you're also going to get a link to our resources folder. The resources folder has today's presentation, some helpful information, and a certificate of attendance. I'm going to drop a link to that resources folder here in the chat in just a moment. So keep an eye on that chat and feel free to request it again if you need it. And as I mentioned at the beginning of today's presentation, we want to answer your questions. So if something pops up for you, go ahead and drop it in the chat. We would love to try and get to it. If we happen to miss it, or if you think of something later today or tomorrow and you really want to figure it out, email us. We're available. You can reach us at support@vernier.com. We're also available by chat and phone call. All of that information is on our website. With that, will questions in the chat be included in the recording? No, Sally, they won't. But if you email us and request the questions in the chat, we can totally send that to you. All right, with that being said, I will pass off the presentation to Nüs and Verle, and stay tuned. We are doing a giveaway at the end of the webinar. You have to be present to win, so make sure you don't leave early. See y'all at the end.
Hello, everyone. I'm Verle Walters. I'm one of the presenters here. And Mike, I want to apologize. I am a Miami Dolphin fan, long time. So go Dolphins. Sorry, I know they're going to lose tonight. So at least you can. The Buffalo Bills don't have to worry about it. Um, Joining me today is also Nüsret. Why don't you go ahead and introduce yourself?
Hi, I'm Hisim. I'm a chemistry specialist here at Vernier, and looking forward to showing you some things in graphical analysis.
All right. So today, we just want you to know that we're always here for you to help you out with anything that's with Vernier. There's News and I are both former teachers, so we know what it's like to be in the classroom and the things you deal with. And a lot of people at Vernier have a good background in education, and so we try to make sure we're there to help you out. A lot of the things we're going to be talking about today deal with the GoDirect sensors. I mean, we're not focusing on the data collection so much today. It's more on the tools that are within graphical analysis that let you do some of these things. So be prepared for that, but they're all kind of based on using the GoDirect sensors, but you can use wired sensors with an interface in graphical analysis. So you definitely are able to do that. And we're focusing on the graphical analysis app. As I said, there's a download link for it that you can get it from our website for free, the free version. And if you can't install it, there's a great web-based version of the app called the Progressive Web App that you can get by going to graphicalanalysis.app on computers and Chromebooks. It's not available on iPads, but it is available on Android stuff. So you definitely can do that. And we have a temporary license. I've noted the temporary license for graphical here, that if you want to use the pro version, you can try that out for at least the rest of this month and do some things. So we'll be there. We'll talk a little bit about things with Logger Pro, but again, that's not our focus specifically, but we'll definitely deal with that. Today, we're really going to go over 6 different activities. News is going to start off with household assets. So this is how we're focusing our tools and within these activities. And News is going to start with household assets and bases. I'm going to do a Newton's second law example. Then News is going to come back and do Boyle's law. I'll do some work with cell respiration lab. We're going to do a lab with density that doesn't even use sensors, so show you how you can do things with that. And I'm going to end up with graph matching. So I'm going to go ahead and turn it over to Noose and let him talk about our first activity.
All right, let me get myself squared away here. So we're going to do household assets and bases. Here we go. Okay, so you might think, why are we doing this? Well, it's kind of an interesting activity because we get questions about it, about how to set graphical analysis up for this kind of data collection. So it's one of the things that we wanted to demonstrate. So I've got a GoDirect pH sensor here. I'm going to turn it on and I'm going to connect to it. I'm using the web-based version of graphical. It's just kind of nice because you don't have to install anything. You don't need your IT department. Let me see, mine ends in Y3. So which one is mine? Mine ends in EAY. Oh, I can't see that. YJ, there we go. And so the nice thing about it is it just runs through the browser, and what's kind of nice is that it it stays available even if you're offline. So anyway, I'm gonna ignore that firmware update information thing. Verl might talk about it later, or if we have time. We have so much planned to talk about that, we could kill the whole time in that. So anyway, what I want you to see here is I want you to see how the sensor connected, but the the x-axis is time-based, and that's not unusual. Most of our sensors connect that way, but for an experiment where you want to collect data in some other format on the x-axis, so this independent variable is going to be something other than time. How do you do that? We get this call all the time. So what you do is you go down to the mode option and down in the bottom left, and this is where you can change everything you want about time, but you can also change the way we collect data. And so for an experiment like this, where I'm going to be comparing the pH of a bunch of different substances, I do want to use events based, and so I can label the event whatever it is. I'm going to do a Boyle's law later and it'll be volume, but this time it's going to be a sample. and then I'm done. And then what happens is the software now is ready. You'll notice there's two buttons instead of the one collect button. And so there's the option now to, wait. There's no rush. Right now, the pH probe is sitting in the storage bottle, and so maybe for whatever reason I want that data, so I can say keep that, and I can actually type in a word or a number. The free version, you're limited to numbers, and the pro version you're not. And I want to show you that a little more dramatically. So what I'm going to do, to save time, because I don't want to go through all 6 of these and bore you all, I collected some data previously. Let me bring the file up here. And so this is a file that I started. And so I've got vinegar, baking soda, and 7-Up in the first 3 test tubes. And so let's look at what it looks like when you're collecting data for, the 4th test tube. This is also a good example of, hey, you stopped collecting data. What do you do if you want to add more data to your data set? Well, you would click append. You would not click start a new data set. So I'm just going to add more to this. And what I'm going to do is I'm going to put the probe in the 4th item. Let's take a look and see what the pH looks like. And so you can see the pH is high because it's ammonia. So what you would do is you would wait until the reading stabilizes, and then you would click keep. And then in the free version, you would be limited to putting in a number. That's all you can do in the free version. So you do need to create some way of keeping track of. Your students could write them down. You can create an annotation using the graph options menu after you finish collecting data. Right now it's grayed out because I'm in the middle of collecting data. I could edit this annotation, that's also a possibility. But how does the pro version change this experiment? That's what I wanted you to see. So, we're comparing free and pro. And so let me go ahead and put the probe in the next substance, which is this Malox, or, Phillips milk of magnesia. And so let me let that stabilize a bit. And then I'm going to hit keep. And this time, instead of writing in number, I'm going to write in the actual word. So this is something that is a pro feature, that you can actually add words instead of numbers. The software will let you know and say, are you sure you want to do that? And the other kind of bonus that GA Pro, Graphical Analysis Pro, gives you is this ability to create bar graphs. And sometimes, depending on what you're collecting, sometimes that's something that's useful. This last test tube is lemon juice. And so I'm going to let that settle down, and then I'm going to keep that value. And so I'm going to type in lemon juice. And so I just wanted you to see the difference between Pro and the free version. You can do the whole experiment in the free version, but you can't put the words in, and you won't have the bar graphs. And so I just wanted you to see that. There's one other feature that's kind of fun. With this experiment, at the very end of the experiment, you're encouraged to put some red cabbage juice in the test tubes. And my students loved this. Oh my gosh, this was like so much fun, because it's so visual. And so maybe your students might want to include that in their lab report. And with Pro, you can do that. With the free version, you can't. You have to take a short video. There's no option yet to do an actual graphic, but I could go in here and add a little short video that I took, I don't know, last week sometime. And so here it is, this video of household acids and bases. And so the students could add that to their report. So not only do you have, let's say, I don't think I need the meter anymore. Let me turn that off. And so you can have your data, and you can have a little picture, and of course the graph in bar graph format. So Verle, did I miss anything?
No, I think you got everything.
Okay, so I think it's time for me to turn it over to you, right?
Yes, I think so.
Let me go stop sharing here. There we go. It's all yours.
Right. All right, so the next activity we're going to talk about is Newton's second law, and what I want to do is we have created. So News talked about videos. We created a video of an experiment where we're just apply a force to our go direct sensor cart and move it back and forth and see how the acceleration and the force compare to each other. Here's just a quick look at what that video looks like. And then we have that file already collected that data. So let me open up that file for you. Um, and that's all these files are in the folder for you. So let me bring that over so you can see that. All right, so here is our graphical analysis file of that motion. A couple things about it. So generally, we want to often just kind of use the examine tool to compare what's going on. What's nice is when the two graphs have the same x-axis and scaling, that examining one graph examines the other graph, so I can see what's going on kind of point by point relationship. You might notice here that in the beginning, there's a lot of things, before we started collecting, we didn't move the cart much. I might want to get rid of that data. So a pro feature, not part of the free version, but if I have a section of data that's not important to my analysis, I can go ahead and select that region of data, and I can go and use what's called strike through. And strike through just take the data is still in the data file. It's just it suppresses it from plotting on the graph and won't be used in any kind of analysis. So it's kind of a nice feature to be able to do that. But as I said, this file, we created it with a video. The file already happens to have the video in it. So News showed you how to put a video in, but if I go in here and turn on the video, and again, News said including a video is really only a pro feature. It's not in the free version, but it's kind of a nice relationship between the two of them. So I can go ahead and have that video long. And when I examine my graph, lo and behold, the graph also advances the video, so it kind of controls both if I sync the two of them together. And I can actually replay the whole data collection. Up the top, this little enable replay lets me go ahead and play that whole data collection all over again. So let me just go ahead and do that real fast so I can see what was all in this video of us creating there and then plotting the graph for us. But what we often want to do here is not see force and acceleration side by side. What we want to do is we want to see them all on the same graph. And in all versions of graphical analysis, we can definitely change what's plotted on the graph. Up in the upper right-hand corner, we have our view options button. So we select that, and I can choose between how many graphs I want to show here. I don't want two graphs, I want one graph. And what I really want is force versus acceleration. And the way that we are able to get the acceleration, I can't see my buttons too clearly, but if I click the button at the bottom of the graph, it lets me get my tools here. Make this a little bit smaller so my tools aren't interfering with my web tools. Here we go. So I want to change what's on the graph. I click on the graph axis label. So here I want to change time to acceleration, and there I have a graph of that data. Now, some people don't like the fact that the lines are connected. I definitely liked it when it was the time graph version, but here it's a little bit awkward to see them connected. It's kind of nice. I kind of see maybe a pattern to how it was moving back and forth. But if I go into my graph options, at the very bottom, and that's sometimes people overlook the fact that it's here, the graph options, I can edit the graph options for a graph, and here's where I can change the appearance to show points instead of lines. I can add a title to my graph. You want your students to do more labeling and of the things that they're making, we can do that. I can add an extra y-axis graph that doesn't pertain here. I can manually set up my scales on my graph, but that's kind of nice. I can put them here as well. And this might be interesting again to see the replay of the graph now in this version. So let me just go ahead and replay the data collection one more time so we can see the data plots points come in for those. So here they just come back and forth as we see as he moves it farther and farther, we see they get further and further from the origin as we do those pieces. So having a video that's synced to that is kind of a cool feature. And this file actually came from the set of data files that come with Graphical Analysis Pro. If I'm going to click on New Experiment here and not save this one for a second. The choices here, if I see at the beginning here where it says see experiments, that lets me, that's where I can find some experiments that are already created for us. They all have videos. It becomes great for having a little homework assignment, a pre-lab experiment, or maybe even do an assessment using one of these activities. Or you can create your own if you make the files with data in them that you can send to your students. But these all kind of come in here through the pro version of graphical analysis. Now, I didn't go ahead and analyze that graph data. It looked pretty linear, but we're going to do some other analysis later on with other activities. So I think maybe I'll turn it back over to News to talk about our next activity.
Hey, Verle, I got a question that I started answering and then you finished, so that's perfect. And the question was, do Vernier sensor carts fit on the Pasco tracks?
Yes. So all of our carts over time, we've had the same wheelbase, and they were designed to, because we'd never had cart track for quite a long time. So we wanted to make sure that a lot of people that had tracks could still use our carts, even if they're on other tracks. So they do fit on Pasco tracks.
I thought that was true, but I thought I'd better ask you because it's my school. All we had is Vernier, so I had no way to check that. All right, guys, I'm going to do a little bit with curve fitting and a little beyond what Verle did, and I'm also going to do some linearization and interpolation, and we'll talk about calculated columns because I'm going to be doing that, but I won't need a custom expression. So here's what I'm going to do, and there was a question in the chat about printing, so we will look at quickly. We'll look at a report. I'm going to do a pressure sensor this time, and there was a question about how did you connect the sensor. These Bluetooth sensors, you turn them on. These sensors can also be connected by USB, but we're trying to impress you, so we're going to do it by Bluetooth. And so in the web app, you tell it, okay, I'm connecting a wireless sensor, a whole bunch of these pop up. Every sensor has a unique identifier on it. This one ends in R3, so there it is right there, gas pressure sensor ends in R3, so I'm going to connect to it. And that's how you do it with Bluetooth. With USB, you just plug it in. Okay, and it's pretty straightforward. But like I said, we want to kind of impress you. Now, notice that it also a time base, right? And Boyle's law, if you're familiar with Boyle's law, it's the relationship of pressure to volume, not time. So I got to do the same thing I did before. I have to go into the mode screen and change the mode from time to event, and change this value to volume. By the way, chemistry teachers, if you were doing a titration, it would look almost identical to this. And then the syringes are calibrated in milliliters, so I'm going to leave that alone. And then you'll notice a very similar screen to the one I had with the pH probe. And so the events with entry, what's cool about events with entry is there's no anxiety. You can hit collect anytime you want because there's not a clock running, right? With this experiment, you set the syringe to 10 milliliters. You've got 10 milliliters of air in there. And so I'll start with that point, and I'm just going to click keep, and it's going to say, what's the volume? I'm going to say 10 milliliters. And there's an adjustment. Some of you that might have done this experiment, I'm going to try to keep it simple for tonight, and we'll look at my data and we'll think about the adjustment. And so I'm going to go and push it down to 5 milliliters. Normally you wait for the meter to stabilize. I'm going to call that good. This is a really good experiment for 2 people. I'm going to pull that syringe all the way out to 20 milliliters. You can see how the pressure is dropping. That may or may not surprise your students. And so let's put that in. I'll put one more point in. Normally, you would have the students do a whole bunch of points. I had mine do every 2 milliliters. But for our purposes tonight, what we have on the screen is going to be fine. So that's 15 milliliters. All right, and I'm going to call that good. So I'm going to stop collecting data. Now, you saw with Verle did it, the data kind of laid out kind of linearly, but when I try to do a curve fit, so this little doodad at the bottom here, this graph options, oh my gosh, you're going to use that the most. So I'll try a curve fit here, and let's see what it looks like. Well, by default, The software always goes to linear because, gosh, you do so many linear fits. But under this menu, there's a whole lot of choices. And so you can have your students just do a little exploration here. Proportional means it goes through zero. You can try a quadratic. Ooh, that's not too terrible. Let's try a power fit. Ooh, baby, that's looking really good. We taught that it's an inverse fit. Why is it not fitting? Keep that in mind because we'll talk. We can talk about it later. It's the correction that I didn't put in, and so now that looks like a pretty good fit. And so you can get this. You'll get the particulars about this power fit. Y equals ax plus a times x raised to the b power, b being not -1 like you would hope it would be, and we can fix that later. But we'll see how the time goes. I don't want to kill too much time. But what is common, and this is a good question that we get from a lot of customers, is like, can you do calculations in graphical analysis? Well, yeah, you can. And so far, everything I've showed you is free. And honestly, nothing tonight I'm going to show you with Boyle's Law is not going to be free. But I'll point out some things here. So commonly, P is proportional to 1 over V. So commonly what teachers want to do is they want to linearize that. So what is P equal to? If you write P equals 1 over V, you need a constant. You need something, to make that into an equality. So what you'll do is take the volume column, the 3 dots. Let me make this a little bigger so you guys can see it better. So when you're teaching, be aware of that. There's this option under app preferences to make things a little bigger. So 3 dots. Click on that, and this time what I want to do is add a calculated column. And so this column is going to be my inverse volume. So I was a bit of a unit Nazi when I was teaching, so they had to have their units. And then what you do is tell Graphical what to do. And so a bunch of built-in functions. Okay, now notice the one that says custom. If you're on free, or what our marketing people call basic, if you try to click on that, it'll say, oh, you need to get a key. But for this experiment, a over x is going to be fine, right? And so if I choose that, then what I just need to verify is that I can change the 1 to anything, or else I want to make sure I'm on the right column of data. Which if the students pick the wrong column, it's not the end of the world. You can fix that. So you hit apply, and then you go, wow, Deuce, that was totally not very exciting. So let's change the x-axis, the independent variable. Let's change that to the inverse volume. Ooh, baby, now that's starting to look sort of linear. Okay, and so let's do a curve fit on that, and we look at that. Let's see how good Noose's lab tech. Oh my God, it almost looks like I'm cheating, right? Because the R value is the best you can get is 1. So it's a measure of how close the points are falling to a line. So this is actually not bad. And then y equals mx plus b. And so the m is the slope, but that's also the constant for the, if you're trying to show, p equals some constant k over v. There was a question in the chat about printing. I'm gonna take 1 minute to show that. If you want your students to show both graphs, you can actually display both. This thing that looks like a window with a bunch of windows in it, if you click in it, you can have up to 3 graphs. For this experiment, 2 graphs should be plenty. And so you can have, not only can you have separate graphs, so down here I can say plot just the pressure, but I can also have separate statistics. So I could have my statistic, whoops, I don't want statistics, I want a curve fit. And so I can have, my power curve fit in this window with its statistics. Now, I zoomed up a little bit here, so things are a bit ugly because it's taken up a lot of space. So be aware of that. I did that so you guys could see it better. And getting that question about printing, if you look under the file menu, there is no option to print. We gave up on printing with Logger Pro. Every printer on every possible printer on the planet printed from every possible operating system. Are you kidding me? That was just, every time Logger Pro got updated, people weren't able to print. That was like the most common thing. So Two possibilities. One is take a screenshot. That's so common now. Just take a screenshot, and that file is universal. You can do anything you want with it. The most common universal file, if you go to export, is the PNG file. And so the PNG file, there's the graph one, there's graph two. The beauty of that is you can copy that right out of graphical analysis and you can drop it right into, let me see, I want to go to my drive here. I don't remember if I shared this. If I will, if I haven't, I will. I was teaching forensics the last few years I taught, and I was having the kids submit their lab reports electronically. So that PNG file is totally universal. And so in any document that you might create, you can paste that file right out of graphical analysis. So you don't have to actually save it unless you want to. If you have the Pro version, it will create a PDF. The PDF option is only available with the Pro version. So it puts in, if you have two graphs, it'll put them on one screen. So, Verle, did I miss anything?
No, you didn't, but the question was, there's a question specifically, I'm not quite sure how you're connecting, and maybe you can run through the steps of connecting a little bit slower so they can see that. Can you do
You want
that?
me to go do that again?
Yeah, just go through the how to connect that pressure sensor one more time.
Sure. So tonight we made the decision to use Go Direct sensors. Okay, you can use our wired sensors interfaced with a LabQuest or with a Go Link, but you know we have so many choices. We thought we better stick. Whoops, the sensor was already connected. Let me get disconnected so you can see what I'm talking about. So what you would normally do, you would go to, if you're using the web browser, you'd open up Chrome and you would type in graphicalanalysis.app, and what will happen is you will see this screen. So you want to collect data with a sensor. So you click on there, and now you have two choices. You can plug them in. Even the GoDirect sensors can be plugged in with the USB cable that came with them. You can also use any of our interfaces to connect. The older style sensors, the ones with white plugs.
Except a Lab Pro, you can't use a Lab Pro.
No, that's why you notice no Lab Pro is available here. So if you've got any of those 20-year-old interfaces, sorry. But tonight we kind of thought, yeah, we want to impress prospective, buyers. So I'm going to click on wireless. Now, every GoDirect sensor has a built-in radio that sends out a Bluetooth signal. So when you push the power button, the red LED indicates that it's sending out a signal. You're in your classroom with 10 of these. How do you know which one is yours? On every GoDirect sensor, there is a unique identifying number, and this camera's not good enough for you guys to see it, but that number ends in the letters R3, and usually that's all you need. So you scan down until you find yours, and then you click pair. So this would be true for all our GoDirect sensors. You would just simply go and click wireless and then choose from the menu which one is yours. Can you connect more than one? Absolutely. You're doing a pressure temperature experiment. You could have a temperature probe and a pressure sensor connected at the same time. Even mixing the types, you could have a wired pressure and a wireless temperature. It would all work. Okay. Did I answer it okay, Verle?
I think so.
Okay. I'm going to turn it back over to you, and I'll go pay attention to the to the chat.
Yeah, so sorry, there are good questions coming in, not necessarily going to be able to get to all of them. Hopefully we will.
Yeah.
A couple of things was how many units are in the in RMSE. I don't know how we decide that. I'm not sure. It's not user controllable. I'll definitely ask our group about that. And the other question was any way to keep that, if you have a curve fit dialog box up and you go to print and it moves, and we are aware of that. That's something that we need to fix. So there's just trial and error of placing it, looking at the screen and going back and forth to get it perfect. I apologize for that. Okay, so our next activity that we're going to look at is from biology. It's a cell respiration file, and we'll look at some various tools associated with that. So let me go ahead and go back to my graphical analysis application, and I'm going to pull up a file. So I'm going to go to a new experiment, and here's where I'm going to choose a new file. So here I have a file already exists, so I'm going to choose new file, and it's going to look in my folder where I've already have cell respiration ready to go. This experiment was actually one that was captured data from our Logger Pro software. I decided to bring that data in here in a manual session, so I was able to copy and paste that data. Nüs is going to go over that very specifically in our next experiment, but for now we're looking at the data of CO2 versus time for some respiring peas. And so for this one, the technique or the question that I always ask is, what is the rate of change of the CO2 level over time as the peas are respiring? And so a lot of different ways to do that. So I've turned on a tool, it's called the tangent tool. So if you look in my files, my graph options, you'll see that I have the tangent tool turned on. Now this is more used in physics than anywhere else generally, so I apologize for bringing it to the biologists that would never choose to do this specific tool in this specific activity. But it just lets you know that it's basically looking at several points around this one point, same way we do to create derivatives in our calculated columns, and it's giving you a representation of what the rate of change at a specific point is based on where you're looking. So you can always kind of get a sense for the rate of change just by looking at the points in the data set. But we know that we want to kind of use all of our data points. So the more common thing would be a curve fit. But we've already seen Nüs do a couple of curve fits. I'm going to do a different type of curve fit that's part of only the Pro feature set, and that's using a manual curve fit. So in the lower left-hand corner, again, of my graph options button, I'm going to choose that, and I'll see my option for adding a manual fit. So the manual fit basically gives me a line with several points in which I can use to edit that. I can the two ones in the end allow me to move the position of those points around the graph so I can align them with my data. The middle graph allows me to translate the whole graph without changing its slope. So if I've got the slope kind of where I think I want our rate of change, I can move that piece and I can get there's a manual curve bit for my data. It's very similar to throwing a piece of spaghetti on your data points and trying to align it just right so you can get the equation based on your best line of fit for the eye. All right, so that's really nice. One of the other techniques that where manual fits use most often, IB students tend to need to use this feature, and they use this feature also along with error bars. So our sensors have, I can show error bars on my graph. Error bars are just basically saying that we know the sensor has some uncertainty in how it measures. And although I have a data point when I measured it, somewhere within the range of that uncertainty is where the actual measurement is, and we get to show that. So I can turn on error bars. Again, error bars are a Pro feature only. So I'm going to go into my data table. I'm going to click on the CO2 sensor and choose my column options. This is where I can name my column and give it units and so forth. And here I want to go down and choose to show error bars for this. For the CO2 sensor, it's kind of complicated. It's like a 5% error plus or minus 100 parts per million, depending on where you are. I'm going to keep it real simple. I'm just going to say it's going to be a 100 parts per million is over the entire range, which is not totally true, but it will work for our purposes today. So our I'm going to say an error of within 100 parts per million of our measurements, and that's kind of the range of where our data points fall. So that's where they are, but they're somewhere within all those little error bars. And what our students in IB do is they're tasked with not fitting the curves necessarily themselves, but fitting the range of the error bars. So they may want to come in here and do a second curve fit, a manual. I'm sorry, not one. Excuse me. I want to do another manual curve fit, and I can add a second one to do on either side of my error bars. So I can say, oh, my data is somewhere going to fall between within that range between those two lines, and that helps us do those pieces. So that's error bars and manual fit. The other thing I wanted to talk about with this experiment is the idea of multiple graphs dealing with multiple data runs. So this experiment actually has students go through the experiment 3 different times. And generally, the instructions have them collect the data of the first one, do their analysis, collect the data of the second one, do their analysis, but sometimes they just collect all the data in the one and come back. And we know that when we collect the second run of data, the first one kind of disappears. And let's talk about how we get them all back again. So here I'm going to go ahead and get rid of my curve fits. And I'm going to go ahead and also get rid of my error bars. So I need to go into my, not my data set, but I need to go into my column options here. And I'm going to turn off my error bars. And so I have some information about the 3 different trials, and I've saved them in notes. Now, notes is a feature that's a part of our Pro feature set, but there's different ways in which you can put this information on the screen, even in the free version. One of them would be to change the name of the data set. So my data set, the first data set had P's at 22 degrees Celsius. So I could actually come up to my data set and rename it. This is true for free, the Pro and the Pro version. I can change this to say P's at, if I can type 22. All right, so I can name that set. And so that's kind of helpful. But the question is, what do you think, and this, and I can't emphasize enough how important this is give your students the opportunity to think about what the data is going to be before they collect it. And we can do that using the prediction tool. A lot of times students, I know my smarter students that I had in physics, they would always wait and listen for the answer, and they say, of course, they rationalized what they thought it was going to be, and they said, yeah, that's exactly what I knew it was going to be. But having them have to put a prediction out there really improves their understanding, because they have to commit to something, and they don't always like to do that. So and again, going to our tools, we can do an add a prediction tool. And add a prediction is just a drawing tool. It lets me to go and say, okay, if I'm going to do, if you happen to notice my notes, the second one was at 12 degrees Celsius. Is what do you think the rate is going to look like if I collected at 12 degrees Celsius instead of 22 degrees Celsius? And they can then draw on the screen to what they think the graph is going to look like. And so that's kind of an important tool to get them to do. It doesn't have to be done in the software, do it on paper to get them to commit to some thoughts before they actually do the collection. But like anything in graphical, if I want to change what it's showing, I just have to click on the thing I want to change. Since I want to see that new graph, I just click on the y-axis label. I see that I have my second data set. I could go ahead and put that there, and I didn't do too bad guessing what I thought that was going to be, so that wasn't too bad. I might as well go ahead and show you all 3 of my points. So there's all 3 trials for this one experiment. And so kids can make up the graphs to look like they want to have to turn in. I can go ahead and turn my prediction off because I'm done with that tool. One other nice thing about that we can do with the tools is to actually show a legend of what's plotted here. So if I go into my graph options, common theme to go here at the top, I have my graph options button. So I can turn that graph options on. I can make that a little bit bigger. And graph options is not a pro tool. It's definitely a free tool. And you see that actually what the labels come from the names of the data set. So it's a really good practice to actually change the names of the data sets. When you do this, you can help illustrate them. Nüs is going to show us a little bit more about the changing the names of data sets in his next activity. So I won't hold you up to doing that, but there's some more things you can do. So Nüs, ready to talk about our next one?
Oh, it's me, my turn. Okay. I love the tag teaming action here. Okay. So the next one that I'm going to attack is the manual entry option. I was using this back in the graphical analysis is a recycled name. Vernier's had graphical analysis since the 90s, maybe even the 80s. I'm trying to remember yeah, there was an Apple II version back in the 80s. So you're doing a density lab, and I threw the copy of the experiment that I do in the shared folder. So this is, I called it density challenges for metals and for liquids, and so that's in there, just left over from does it have a date on it? Oh my gosh, February 5th, 2010. Boy, that is a kind of an old experiment. But what you might want to do is you might want to have the students collect the data and then put it into graphical analysis, and you would use this option called manual entry. And so at this point, what you need to do is it's just a generic XY graph, and so you might have the kids explore, or you might tell them, okay, well, mass over volume, what's going to go on, and it doesn't really, if they mess up, it's not the end of the world. You can change those axes in a heartbeat. But if you click on the three dots next to the X, and where we're likely going to want to put our volume values, and then you can type in volume, and of course the units. And if you're doing solids, it's probably going to be cc's, and if you're doing liquids, it's probably going to be milliliters. I'm going to leave it in milliliters because you'll see why in just a second. And so I'll also do the same thing. Notice that now the x-axis says volume, and so do the same thing with the y-axis. Go to the options for that axis and put in mass. Of course, it looks a little wacky the way I typed it. So these three dots that are next to things are very, very, very handy. And then what you can do is the students could just measure the values. Of course, the volume they would have to calculate possibly. Depends on the experiment. If you look at the one I put in there, they use a graduated cylinder. I actually have some data. Believe it or not, someone asked about LoggerPro. This is data that was in LoggerPro where my students, were doing this in 2010, but I don't have any data from the 80s and the 90s. That was way, 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 way back. But you can take the data and you can just copy and paste it if the students have it on maybe a chart like this, or they can type it in. It's kind of your call. I can go in here and grab data that that was collected and copy it, and then go back to graphical analysis. Hopefully I'm doing this in the right order, and paste it in. That looks about right. Yeah, the mass would be varied. And so this one, what was that first column? That was water, wasn't it? Let's take a look here. Yeah, that was water. So like Verle showed you, you can change the name here from the y-axis. You can also change it where it says data set. You could put in there and type in, what the data set is. If I can spell it right. Of course, there's a million different ways that people say water, right? And so, we can add more than one data set. We click right next to where the data set one was, and we create a new data set. And so we can go back to this column, and we can go, this was one where the kids, every group made 10 milliliters total, and then, or pretty roughly. And then what they did is they brought it up to the front of the room, and I had a 100 milliliter flask or a graduated cylinder, and the kids would pour it in, and we'd get a density column. So that was what, Karo syrup. And so let's rename that, just like Verle did before. Looks like I did that the other day. Okay, and so now where'd the other one go? Well, common question, right? What graphical analysis does is it automatically stores runs. You don't lose your data, it just automatically stores them. So you go to the y-axis to show that data, and then you can do curve fits. You have more than one, like Verle showed earlier. Same idea, right? You can do the curve fits and look at the slopes and compare the slopes and all that kind of thing. And so manual entry is definitely available to you. You can do calculated columns, you can do all kinds of things, in the manual entry without using a probe. The one other thing I wanted to show you before I turn this back over to Verle was a feature of Graphical Analysis Pro that you might want to experiment with. This is my phone over here, and what I'm going to do is I'm going to share my data with maybe one of my students, or it could be one of your, you're doing a demo and you're sharing it with your class. And so the source of the data, which would be the teacher, or maybe one person in a lab group, they will create a sharing session by clicking on the little, I like to call it a TIE fighter, but it's like the little sharing icon here. And what it does is it creates a session code. Anyone out there that's got graphical analysis, go ahead and pro, has to be pro. So on my phone, I go on here and I click on data sharing. That's what I just did. And I type that code in. We actually, when this was came from the COVID days, we actually told the programmers, we said, these have to be simple for people that are using phones. We can't be having a whole bunch of capitals, and we can't have a whole bunch of ones and L's and all that kind of zeros. And so they tried to make those codes pretty simple. And so Shazam. Now notice that on my phone, it didn't do the analysis. We share the data. The students that are getting the data, they have to do the analysis on their own. So if you want to try it, the code is right here. Go ahead and write, go ahead and write that down. Or you can get it from the, when Dylan shared the folder. And then you can do this with your students. That code is good till the end of the month. And if you want to do it with your students, by all means, go ahead and do it. All right, Verle, I'm turning it back over to you, because
Right,
we
sir.
are running short on time. And so I'm going to give you, I don't know if you'll be able to squeeze in what you want to do or not.
I think so. As long as I make Dylan really squeeze at the end, or all little last ending pieces. The last thing we want to talk about is a very common physics experiment that we do, physics or physical science experiment we do early in the year, which is graph matching. And it's really a great tool to help students get the relationship between graphs and the numbers. And in this case, it gives a kinesthetic approach to their motion as well. So I'm going to use a motion detector. I'm actually going to connect it. I'm going to connect the way that News hasn't been doing it. I'm going to do USB. I have the installed app, and because I have the installed app, if I connect my sensor via USB, it's going to automatically start, if I can plug in my sensor correctly, it's going to automatically jump to the fact that it's connected. I didn't have to go through the steps of connecting it. That's what we did in our older Logger Pro software. When you use the browser version that News showed you, you have to go through the steps to give permission, even when using USB, for the browser to do that. So there's going to be that extra step. But here I want to do graph matching. And so we built that into our applications since really way back at the very beginning. In our graph options menu, if I scroll down, while I have a motion detector or a sensor that detects motion connected, sensor cart would do this too. I go to add graph match, and I can choose a graph from which to match. So here's a target for me to match. These are all very simple 3-line segment sections for the data, and then I just I'm putting my hand above my detector, and I can't even get high enough to get that match. But students generally choose to walk in front of the motion detector in order to be able to try to match that setting. What's new, a new feature we added just this year, is the ability for you to modify these graphs and create your own graph matches. A way you can do that, if I again go back into graph options and choose add graph match, you'll see modify graph is an option. And here it shows you the 4 points that were actually used in order to do this experiment. And that lets you make that change. So here, if I want to actually try to match this, let me make this something that I can do. So maybe I'm going to do 0.7 instead of 0.8 for how high that is. At about a third of the way through, 3 seconds in, maybe I want it to be, to go down. So let's go down to 0.5. And then I'm going to make it easy on me. I'm going to stay at 0.5 for those 3 seconds there. And then after that, let's go back down to even smaller, 0.25. So I can actually change that. I can add more points in here to make it more complicated, but I can also just create my graphs. And once I create these files, I can save them and then give them to my students to try. So I'm going to go ahead and apply that. I already have a match on here. If I want to get rid of this match so I don't have to my attempt, I should say. I want to get rid of that attempt. If I go into my y-axis menu here under the data set and I choose to delete the data set, I cannot actually delete the last data set, but if I only have one, it actually erases all my data in that data set. So I can say, let me delete that data set. So now I can collect data this time. Let's see if I can actually match this one. I'll give this one a shot. There's, I see, here we go. Oh, it was not too bad. Somebody move my hand. Oh, hold still up there. And kids really get a kick out of doing this, and most of the time they have to try it a couple of times in order to be able to get really good at that. And what we've done, those of you that have used our Logger Pro and used the Vernier, the book Physics with Vernier, they had 8 different fits that you could, graph matches that you could do, and we've generated those files, and I've included them in the folders for you so they can do them with graphical analysis. Let me show you just one of those folders, one of those files. So here I'm going to choose a new experiment. I'm not going to save the old one. I'm going to choose a file that I already have. Here's just one of those graph match files that was in the old Logger Pro version. So they see there's definitely more complicated, more points to that. There's velocity matches as well as the linear matches. So there's definitely things that we can do there. So that's kind of a neat piece. All right. So that's the last of our activities. Let me go back up here. I'm not going to save. Let's go back and bring up our agenda. One thing to point out in the file that we gave you, we have additional resources we pulled together for you so to make them easy to link to. Where there's a link in all of these folders, links to the shared files, so you can always easily get to them. For those of you that are transitioning from Logger Pro and need to learn more about graphical analysis and how that transition, there's a link to information about that on our website. If the week or so, 2 weeks trial that we have for the free Pro is not long enough, definitely request a 30-day trial for the Graphical Analysis Pro if you want to try that some more. And if you need information on how to activate Pro, we have some links to how to do that. It's a little different on an iPad and iPhone compared to what it used to be on the other, and how it is on the other one. So there's some instructions for that. We'll give you a link to the user manual for graphical analysis. It's certainly out of date. We haven't updated in a while. We're looking more of including instructions within the app and also a more web-based tool for doing that. So we're waiting to do that to get you a better manual coming in the future. But if you want to talk about how to, we showed about importing a video and syncing it. There's a link to instructions on how to do that if you aren't sure. If you want calculated columns, Nüsret did calculated columns with different pieces, but you may want to actually create, there's a lot of different functions you can do, a lot of things you can do, powerful things. And this is a link to the information on the functions that are available if you're using the Pro version and creating your own calculated columns. And here's some information if you want to create files and save and give them to your kids that are already set up. How to create and use template files. So that's a great one to do. And we have some other links to our videos and YouTube stuff for using the graphical analysis and graphical analysis Pro. All right, that's a mouthful. We've enjoyed having time with you guys. Appreciate it. I'm going to turn it back over to Dylan to talk about our giveaway.
Thank you, and amazing work to Verle News. Thank you so much for everything you've done. Lots of questions in the chat today, so truly incredible work staying on top of that. As Verle News have been chatting, I've been entering everyone's names into a random name generator to choose today's winner, and the winner is Steve Scannell. So congratulations, Steve. I am going to go ahead and email you. I have your email from when you registered, so keep an eye out for an email from someone with an @Vernier, just @Vernier domain in their email. If you don't see it in about 10 minutes, check your spam. With that, I dropped a link to a survey. It'll also populate when you close the Zoom. But besides that, I think we're good.
Wow, that was a really fast 6 activities in an hour.
Yeah, you all did an amazing job, and thank you to all of our attendees today. I know it's late, especially on the East Coast, so thank you so much for your time and your energy. If we happen to miss anything from you, please reach out to us at support@vernier.com via email. If you want to call us or chat us, that info is on our website. I know there was a lot of questions, so if we missed anything, reach out to us. We'd love to help. Um, but
Next,
yeah,
next,
oh, and
next
Roy
slide.
shares it's early in Saipan. So, hey.
And thanks, Dylan, for hosting us. You always do a great job of making sure we're on track with things.
Absolutely.
Who's
Thank you. I
controlling
appreciate
the,
that.
the show? Next slide shows them how to get in contact with us.
Oh, good. There
Yeah.
we go.
All right, my fault. I was
I
falling asleep at
forgot
the
who
wheel.
was controlling it, back and forth.
Who's driving? All right, everyone. Well, with all that, we're going to give you a minute back and we'll have, a great rest of your Thursday. So thanks, everyone. Have a great rest of your day.
All right,
All right. Bye, all.
bye-bye.